From there, we'll get started on the very basics. But here's how this works. So far what you've been able to do is you've been able to find the exact values of certain angles that were all in the unit circle. The exact value for the sine of 30. The exact value for the sine of 7 pi over 6. The exact value of the cos of 11 pi over 4. Those are the things that we've been able to do. We've been able to find them. They're on the unit circle, we've been able to find them. Well, what happens if you have something like this? Now I'm going to use degrees to start with today, and I'll show it to you. So, what if I wanted to find the exact value of the sine of 105 degrees? Okay? Now 105 degrees is not on the unit circle, but I can find two angles that are on the unit circle and maybe be able to calculate what the sum of them are. So where I'm getting at is this. The sine of 105 degrees is approximately right there, right? So I'm looking for the y value. Okay, so these are two angles that add to give me 105 that I actually know the exact values for.
90,
Say again?
90,
You don't know 15. You do know 90.
1645.
1645? Those would work, right? Okay. Now, what you're going to find, I want you to watch this because this is where the identities come in. I can't just take the value of sine 45, which is root 2 over 2, and add it to the value of 60, which is root 3 over 2. I can't just add those two values together because this doesn't read sine 60 plus sine 45. It reads as sine 60 add 45. Okay? So now we're going to need to use what we call an identity to solve it. So the identity reads like this, and again, this is way, way past you right now, but I want to show it to you so you have another idea. This can be rewritten as sine 60 cos 45 plus sine 45 times cos 60. This is what I refer to as an identity. We are given those identities. We have to find the ones that work for us. They are made to make the question easier. All right, what is the sine of 60 degrees? This is what I mean. When we did all that unit circle work, this is the unit we needed for. You have to be able to nail these. What's the sine of 60? Root 3 over 2. I just told you that. What's the cos of 45? Root 2 over 2. What's the sine of 45? And the cos of 60? 1/2. So I substitute those ratios in for my values. For my trig sign, my trig ratios. Multiply it out. The exact value of the sine of 105 degrees is root 6 plus root 2 over 4. So if you were to punch into your calculator right now, what is the sine of 105? And then you punched in your calculator root 6 plus root 2 and divided by 4, you get the exact same value as a decimal. We need to be able to leave it as that right there. We need to do this without the calculator. So this is what we call an identity. Now an identity makes a question easier for us. You're given these lists of identities. You have to pick the ones that work for you. Lexi?
So in the very beginning of the question, when we defined something for 105 and we chose 60 and 45, that would not be given to us.
No.
would normally.
No.
So
Why
how
would
do
it
we
be given to you?
How do we decide? I thought it was given to us in the identity to use
No.
1645.
I picked 60 and 45.
But it doesn't matter. You can pick like 90 and like 50.
I could have used 135 and 30,
But it has-
subtracted them.
Oh, okay.
You have to use two angles that you know all of the values for
Oh,
on the unit circle.
okay.
And you only know 30s, 60s, 90s, and all the 45s.
Okay.
So you have to use those. But don't worry about it. I don't need you to know this and understand this now. This is the end game. This is where we're leading to. So what needs to happen today is we need to start with our very basic identities. Okay? The reciprocal identities, we've gone through these already. Now, again, these are used to simplify questions, to make questions easier. So when we do an identity, we have to do these tables, and we have to set them up, and we have to solve them so that our left-hand side and our right-hand side match up. We prove them. So in this section, we're going to spend a lot of time proving identities to be correct. Okay? So our reciprocal identities, again, you'll have them they're given to you on your cheat sheet. But what we know so far is this. Cosecant x is 1 over sine x. Secant x is 1 over cos x. And cotan x is 1 over tan x, or cos x over sine x. Okay? So far so good? Now, identity number 1 that you are going to use often is one that we've already somewhat looked at. And that's this. Cos squared x plus sine squared x is equal to 1. We know that, look on page 188, we know that from our triangle. The x value of the coordinate is cos theta, the y value is sine theta, and the radius is 1. So this is what we call the Pythagorean identity. Okay? Now from this identity, we can create 2 or 3 more identities from that guy. For example, let's say I divided all of this by sine squared theta. Okay? So that by sine squared, that by sine squared, and that by sine squared. I can create another identity. Cos squared over sine squared. What is that? Cotan squared x. Okay? Sine squared divided by sine squared? 1. 1 over sine squared x is cosecant squared x. This is the Pythagorean identity number 2. This is the second one that we're going to work with. How do you suppose I get the third one? Yeah, divide all of this by cos squared. So what's cos squared x divided by, let me just delete this, or erase this. We'll do this again. Cos squared x, cos squared x, cos squared x. Alright, what's cos squared over cos squared? 1 plus sine squared over cos squared is what? Tan squared x. 1 over cos squared is? Secant squared x. I have just created 3 identities. They're referred to as the Pythagorean identities. You do not need to know how to get to them, but you sure need to know how to use them when asked upon you. Okay, so these are three identities that we're going to use. You're going to have approximately 12 identities that are given to you that you need to be able to use. Okay?
Are we gonna have to remember and keep?
They're going to be given to you. So, do you have to memorize them? Is that your question?
Yeah.
Did I answer your question?
Yeah.
Okay, so yeah, you get them as part of it. Okay, so I'm going to show you some more uses of this and what we're going to use for it. Take a look at the sample on page 189. Okay, now the first thing that we need to do is we need to talk about non-permissible values. How do I ever get a non-permissible value? What has to happen?
The denominator is equal to 0.
Excellent, thank you. The denominator is equal to 0. So in this identity, they're going to want you to prove that this is true. Cosecant theta is equal to cotan theta over cos theta. Okay. So the first thing we got to deal with is the non-permissible values. So right now it looks like I only have one fraction, correct? Yeah? So therefore cos theta can't equal 0. Right? And again, what you're going to need to make this a lot better for you is you're going to need to have that unit circle by you, because you've got to use it almost every question now. Alright? So, if cos theta can't equal 0, what can theta not equal? What are the angles?
90
Yeah. 90?
and like 270 or something.
90 and 270? Sure. And then I can keep going if need be, right? That's where cos theta is equal to 0. Alright, but what is cosecant theta actually? 1 over sine theta. So that in theory is a fraction, right? So therefore sine theta also can't equal 0. So what else can theta not equal?
180. Oh no.
Is that right?
Yeah.
So therefore, my non-permissible values, the first things that I write out, theta can't equal 90, 270, 0, 180, or 360. Okay? Now they're probably going to give you a domain that's going to go from 0 to 360. They'll probably give you that. Alright? Now, it says numerically verify that theta equals 45 as a solution for this equation. Okay, first things first. Watch this. When we do a proof, a trigonometric proof, we never use the equal sign, except at the very start and the very end. If you use it, you're going to lose marks. So what do? You simply draw a line down. And your objective is to prove that the left side equals the right side. Now, I'm going to do this without the 45 degrees for right now, and then I'll prove it with the 45 degrees. So I'm going to use my identities and see if I can prove that the left side equals the right side. Now, the rule of thumb is this. As we get into much more difficult identities, you work with the tougher side, and you only work with one side if you can get away with it. So my objective right now is to make this look like that. So using identities, I'm going to see if I can do that. First thing I'm going to do is I'm going to change cotan theta. What is cotan theta according to my identities? So I have cos theta over sine theta all over cos theta. Now I'm going to put this in brackets because I substituted in for cotan. Right? So that's like saying cos theta over sine theta times 1 over cos theta. Agreed? those cancel. What am I left with? 1 over sine theta, and what is 1 over sine theta? Cosecant theta equals left-hand side. There's my proof. Okay, so we start on the more difficult side, and we try to get it so that it equals the smaller of the trig ratios. Equal signs are only at the start and at the end. They do not occur in between, because it's not an equality, it's an identity, which means that we are showing how they are similar to each other. Okay? We have a lot of these to do. We're going to get at that. Okay? And again, two things you need. You're going to have your equation sheet beside you. You're going to have your unit circle beside you. It will make things a lot faster and more efficient. You'll get more done. Okay? Now, they want us to prove it for 45 degrees. So I start by writing out cosecant 45 degrees is equal to cotan 45 degrees over cos of 45 degrees. All right, when I use numbers, I'm now going to use both sides. Okay, so cosecant of 45 degrees is 1 over sine 45 degrees. Now get this straight, because some of you did this wrong on your test. It is 1 over all of sine 45. It's not sine of 1 over 45. This one goes on top of it. What is the value of 45 sine of 45 degrees? Root 2 over 2. So I have 1 over root 2 over 2. Which, I reciprocate this, gives me 2 over root 2. Right? I'll probably leave it there. If I were to rationalize it, it would just give me actually square root 2. I'm going to leave it here for now. You don't have to overcomplicate things. Let's go up here now. Cotan of 45 degrees is cos over sine at 45. What's the cos of 45 degrees? Root 2 over 2. What's the sine of 45 degrees? Root 2 over 2. When I divide the two, what do I end up with? 1. This is 1 over cos 45 degrees. What is the value of cos 45? Root 2 over 2. So that gives me 1 over root 2 over 2, which is 2 over root 2. My left-hand side equals my right-hand side. On the exam, you could use this method instead of the other method. And you can choose whatever values you want to put in to solve. That's perfectly okay.
I have a question
Sure.
about the cotan. So, how did you get that again?
Cotan 45 is equal to the cos of 45 degrees over the sine of 45 degrees. The cos of 45 degrees is root 2 over 2. Sine of 45 degrees is root 2 over 2.
Well, yeah, like I get that part. I just mean like when you first put it in there on top of the equation.
It was given to me.
Oh, but okay,
The equation's given you right there.
right there. Okay, never mind.
Okay? So far okay? They do, in some of these questions, ask you to graph the left side and the right side. Alright? But if you graph them, you can use only sine and cos. So, when you punch them into your calculator, everything has to be in sine and cos. So you can't use cotans. Okay? I suppose you could use 1 over 10, I guess. That's a possibility. They're gonna give you funny graphs, but you gotta make sure that they're the exact same graph, left side, right side. All right, let's look at the second example here. Page 199, 190. 10x. So it wants you to first find your non-permissible values, and then second, it wants you to simplify. So I've got 10x cos x over secant x cotan x. So the first thing you do is your non-permissible values. Okay? So again, just looking at that, basically they're all going to be the same. Not 100% of the time, but most of the time. So cos x can't equal 0, sin x can't equal 0. Therefore, x can't equal 0, 90. So give it to me in degrees, or it wants it in radians, right? So 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so x can't equal any of those values here. Now we want to simplify. So we're going to simplify this by using our identities and changing all our tan values to sines and coses. Okay? So tan x is what? Sin x over cos x, right? Times cos x. Secant x is 1 over cos x. Cotan x is cos x over sin x. Okay? Those are our very basic identities. Now what I want to do is I want to cancel. And then I'll multiply them. Okay? So that guy's canceling with that guy. That guy cancels with that guy. So what am I left with on the top? Sin x. What am I left with on the bottom? 1 over sin x. So to write this as a single trig identity, sin squared x. Okay? Gotta flip that and multiply the two. Alright? Another important note, notice where the squared value is located. That's pretty important to you. You always put it between the sine and the x value. Okay? If it's not for that, then it has to be in brackets on the outside, which means the whole thing is squared. But they write it like this, sine squared x. Okay, so far? This is going to be the toughest thing you're going to do. Everybody finds this difficult because there's a lot to it and there's a lot that you have to do with it. Okay? So I'm going to look at another example here. Verify the equation cotan squared x minus cosecant squared x equals minus 1. Alright. So I'm going to do this without the pi over 4 value to start with, okay? Because I want to show you how complicated this can get, or how uncomplicated it can get. Alright. So I got to get this to minus 1. So you look at your identities. I wrote down 3 Pythagorean identities for you. Flip back and find those 3 Pythagorean identities. Alright? Now remember, I need to get this to minus 1. So which one of those identities can I substitute and change one of these out?
Which identity do we use?
The second
The
one?
second one.
The second one, so that's the cotan squared plus 1 equals cosecant squared?
Yeah.
Okay, so then I'm going to do this then. Cotan squared x, subtract, what is cosecant squared x equal to?
Cotan squared x plus 1.
Plus 1, just like that. Okay? Now, you can arrange those identities so it works for you too. So, look at that second identity. What would cotan squared theta equal? Look at that second identity. If I were to arrange it differently, what would cotan squared theta equal?
Cosecant squared x minus 1.
Yes. Okay, so you're allowed to do that. Switch them as one. Okay, now what am I going to do? Transfer the negative through the brackets, right? So what is that going to give me? Cotan squared x minus cotan squared x minus 1. Right? What's cotan squared x subtract cotan squared x? 0. What am I left with? Minus 1 equals the right hand side.
Where's your second cotan coming from?
This?
Yeah.
From my identity. Look at that second identity, Jake. What's that?
So you just put it in?
Yeah, I have it wrote down, but I just.
Cotan squared x plus 1 equals cosecant squared x. Yes?
Okay.
You follow this?
Yes.
So look at that guy. So I substituted in for cosecant squared x, cotan squared x plus 1. That's what I'm saying. I arranged these so that I can substitute in, and then it's going to simplify for me after. Follow?
Yeah.
Okay? So that's what they're used for. They're used to arrange these things to simplify greater problems that we have. Okay? Lex? Stay awake, so I don't have to answer 17 million questions from you in about 8 seconds. Are we okay so far? I know that's complicated. I know that's weird. It's something you've never ever done before. We used to do geometric proofs in grade 10 and 11. We no longer do that, so this is brand new to you. We used to do it proving triangles are congruent and whatever else. Okay, but we don't do that. Okay? All right. You're gone Thursday, Friday? Okay. I'll do 6-2 and 6-3 tomorrow. All right? Okay, so 6-1 is enough for you today to go through and work through all of the questions on 6-1. And I want you to do that. I will give you your assignment in class that will be your only assessment for that chapter 5. Okay, so you won't have a test on 5, you'll have a test on 6. You'll just have the assignment on 5. Okay? Okay, work on 6.1 right now then, please.